is precisely the point where we will depart from. Now, we were studying the net premium, which is this thing here. We were also studying the exponential premium, which is this one right here. And we were beginning to study the variance premium. The variance premium is given by this expression here. Now, the point of all this really long chain of reductions, algebraic reductions, the point is to show you that if R is small enough, remember please that R is supposed to be a positive number. Actually, it is the smallest positive root of certain equation. The equation is one here. So that is the exponential premium comes that expression there. During last lesson, we were learning that if we have an exponential premium, which is an expression given by this thing here, then we can just turn that exponential premium into a variance premium by writing alpha equal to the adjustment coefficient divided by 2. Okay. So if in the expression for the variance premium, we will be able to say that doubling the loading factor alpha has yields as a result a decrease in the upper bound for the ruin probability from epsilon to epsilon square. That means that if you double alpha, then the upper bound for the ruin probability goes from epsilon to epsilon square. If you just have the initial capital, right, then you will have to double the loading factor, right, in order to keep the same maximal ruin probability. Okay? Now, how do you do that? Well, just take this expression here, right, and change alpha to alpha or for alpha half, alpha divided by 2. Another question that will be very important for us during our study of this in this course, you should ask yourselves, how large should the initial capital be if the premium ceases to contain a yearly dividend that is, say, I times U, so that the shareholders can have a dividend, right? So this is a very important question that we will need to address, right? Now, if you take a look at what we have just studied in the last 3 premia, right? That is for the net premium, for the variance premium, and for the exponential premium, there is not even a hint of payment made to the shareholders. So if you are to pay a yearly dividend of I times U, then you should do something else. Now, I will propose you, right, to use this new premium. So from the checkup that you need to do from remark 2.1, okay, it is clear that a premium that ensures ultimate survival with probability 1 minus epsilon and also incorporates the dividend is given by this thing here. That's a looking expression. Where did this come from? Where did the 2 come from? Well, the answer is in here, in this remark. So just check. We will be studying this new premium, right? That is the premium, this variance premium, and the adjustment coefficient, right? So you just have to use the adjustment coefficient and the variance premium plus this dividend. So what we're going to do is we will choose the initial capital so that this premium is competitive in terms of just marketing or in terms of, for instance, what your customers are willing to pay, right? This amount is the minimum capital required to do what? To do this, right? Now, if you put this initial capital here and here, then you will get the so-called standard deviation premium. I would kindly ask you to do it. So take this expression and substitute u for what we just computed. So just put this here and here. I will show you now a quick development of this, of the proof of 2.8. So all I had to do was to just plug in this expression here and here. And I did it by means of just unravel things a little bit, okay? So just like this, right? And then there. And that's it. So thank you so much. Bye-bye, guys.